The work of inverse function is like this, all right? It's flip values of x and y, so it means that if you're asked to find what's the domain and range, you need to find the domain and range of this, and you just flip them. That's the domain and range of your inverse function. But of course, we need also to know how to find the inverse function of our function. Now, if you have f of x equals the square root of x minus 2, okay, the domain here is what? X is greater than or equal to 2. The range would be, range here cannot be negative, but it can be 0. You get that? Therefore, our answer here is that the domain of the inverse, okay, is x is greater than 0, and our range would be y is greater than or equal to 2. So you need only to flip that. To prove that, we will need to find the inverse of the square root of x minus 2. Okay? Now, you might be wondering where I did that for. Okay, it's better that I will explain. You might be thinking, how did she get that? So, you have f of x is equal to the square root of x minus 2. Okay, you see your graph here. All right? Your x is greater than 2. Your y is greater than 0. So therefore, the domain will be x is greater than or equal to 2 and y is greater than or equal to 0. Now, the range then, because you would like it to be like a one-to-one function, will be only flipping this. X is greater than 0 and y is greater than or equal to 2. But I'm going to prove it by means of using the inverse function. So we already graphed x is square root of x minus 2. And so therefore, to find its inverse, we need to put it first in the y form. You still remember? And then after that, we flip x and y. Okay? And then we will solve for y, so we need to free it. And to free it is to take out the square root. To take out the square root is to square the function. Both sides. So x squared is equal to y minus 2. Alright? And so therefore, we need to add 2 on both sides of the equation. So your y is x squared plus 2. Or the inverse function is equal to x squared plus 2. Okay, let's graph it. Now remember, we already have a restriction that our x is greater than or equal to 2. So if I'm going to graph it, I have to show that. Okay, and to do that, using piecewise function, okay, you have here this bracket, x should be greater than or equal to 2. Alright, or 0, I mean. Alright, and then let's see first if I do that. So you have the colon and then put x squared. I'll try for 0, I might be wrong. So plus 2. Okay, as you can see, the restriction is x is greater than 0. I have missed that because the range is y is greater than 0 for it to 1-to-1. Remember, our line of symmetry is y equals x. If you're going to see, okay, that's how it works. But you just need to find, if you're doing this, the problem is like this. You just need to find the domain of this and the range of this and then flip them. It will be the domain of your inverse function. Alright? Now we will go to here, expand the logarithm. I think this is the last one. Now remember, expanding is the opposite of condensing. What did I tell you about division? They will be subtraction. Okay, numerators will be addition. So therefore, if I will expand, this is log 3 plus log of x raised to 5 over 3. Okay? Since these are denominators, minus log of y raised to 1/2 square root is, exponent is 1/2 minus log of x cubed. Now remember, all denominators are subtraction, all numerators are multiplication. Same goes also with condensing. Okay, when you condense, all subtraction goes to the denominator, all addition goes to the numerators. Now we will have to simplify, so this now equal to log 3 plus 5/3 log x minus 1/2 log y minus 3 log x. And that's it. Study your lessons, guys. Okay. All of the equations for circular are given. You don't need to find them. By the way, there are also exponential functions, but I already gave the formula. So all you need to do is to understand. Okay. So the rays of the sun shining over Wallace is given by this function. Distance in miles as function of time in minutes. Now remember, x is always a function of time and y is a function of distance. Alright? So it depends on what you will plug in the value, just in case you wanted to solve the problem. How many minutes? So it means we're looking for t. Alright? And our y is 13. Get that? So therefore, we just equation y equals 14 minus 5 cosine of 0.25 x. Oops. Alright. Plus 1.5. Okay. And by the way, because we are using circular functions, we should be in the radian mode. Okay? And so, therefore, the other is y equals 13. Okay? And we need to find the points of intersection. There's a negative here, but we will choose the positive. Okay? If, for example, there are two, you need to prioritize only 2 points of intersection from 0. Okay? So the first time is at 14 minutes. Okay? Like 13.7 minutes if you round it off to the nearest hundredths place. So the time is after 13.7 minutes. Okay, the coverage of the sun will be about 13 miles. Okay, after 13 minutes of sunshine, or 13.7 minutes of sunshine. That's the meaning of the problem. Now we will go to the next one. How much far has the sun, okay, that's correct. How much far has the sun covers Wallace after 12 minutes? Pardon my grammar, but I'm trying to find how many miles have been covered by the sun after 12 minutes. That's the meaning of that. So therefore, our time is 12, which means our x. Okay? So we will go back to our graph here, and we just have to change our x by 12. And the answer is about 15.1 miles. So it means that after the sun has shone for 12 minutes, okay, the coverage of the sunshine is about 15 miles. That's the meaning of that. Okay, now let's go to the next one. Okay, how to find the vertical shift? But of course, you can always graph the function in order for you to find some of them. It's easier. So y equals 12 minus 7 cosine pi over 4 x minus 2. All right? So from the graph, you can easily find the minimum and the maximum, and that's 5 and 19. And the range then becomes your 5 and 19. Okay? Now, the vertical shift is your movement from 0. That will be from here to here. And as you can see, from the midline to the top of it. And as you can see, the vertical shift is the stand-alone number here. And so, therefore, this is 12. So, that's the stand-alone number. This will also give you the midline. So you see, if I'm going to graph this, that's why it's the movement from 0 to the midline of your graph, and that's equivalent to y equals 12. Now, the amplitude is 7 because that's the distance from here to the top. And it's also that number beside the function, so that's 7. And it's also your vertical shift, vertical stretch. So the graph is stretched by a factor of 7. All right. Now we will go to phase shift. Phase shift is negative C over B. Okay, this is your B and this is your C. But because it's negative C, you need to change the sign. From negative 2, you will use positive 2. Okay? And then your B is pi over 4. And then, of course, because we're dividing fractions, we need to reciprocate pi over 4. It becomes 4 over pi. And so you will have 8 over pi. So it means that the graph has moved to the right side by 8 over pi. Because the phase shift is the same as the horizontal shift. Okay? Now we will go to the period. All right. The period is given by, I'll put it here, I don't have space, 2 pi over b. Okay? Our b is pi over 4. And so you need to flip that. And so it gives you 2 pi times 4 over pi. And so it gives us 8. In a Ferris wheel, it means that the Ferris wheel will have a complete rotation after 8 seconds. You get that? Okay, the radius of the Ferris wheel is 7. The maximum height a rider can reach is 719. All right? Now, let's go here. Find age of t when t is 3. So all we need to do is to change this with 3. And the answer is 7.05. Okay? Then, this is a question is, how many seconds have passed when the rider is about 15 feet above the ground? That's the meaning of that question. Okay? So that means we need to put 15 here. And we have to go back to x. And then we find the point of intersection. Choose the first two. So that's 4.6 and 7.4. Because there are two locations on which a rider has the same distance from the ground. So therefore, there are 2 times on which the rider will be far apart from the ground. And that would be after 4.6 seconds and 7.4 seconds. Okay? That's about circular functions.